Welcome to another unit in this workbook, Statistics. This time we're going to focus on the measures of distribution. With measures of distribution, we're going to take a look at two particular statistics, the first one being the skewness and the second one being the kurtosis. With the skewness, we're going to calculate, first off, the standardized values. Standardized values means we take each value from our raw data set, going to subtract the arithmetic mean, dividing this by the standard deviation. Once we have standardized all our values, we're going to take them to the power of 3, sum all of these values up, and divide them by the number of observations. So it's similar to what we did with the variance. Variance was to the power of 2, and it was just about the difference, not the standardized difference. So similar but not the same as the variance. Well, what does the skewness tell us? The skewness tells us how the distribution looks like. Are most of our values somewhere in the lower valued area or in the higher valued area, or is this more or less a symmetrical, evenly distributed random variable? Well, something like this is called rightward skewed. So we're always talking about where we have something like this long tail happening. And this occurs if our skewness is larger than 0. If the skewness is smaller than 0, we have something which is leftward skewed. So most of our values are in the larger valued area. So well, if we have these two cases, we might also consider what happens if we have a skewness of 0. Then this is actually symmetrical, or at least distributed in a way that there are as much small as large values. And well, that was already everything there is on the skewness. So let's turn to the second statistic, the so-called kurtosis. For the kurtosis, we're doing almost the same as with the skewness. We're going to first standardize all of our values. That's the part inside the brackets here. But then we're going to take them to the power of 4, which gives us as a result a statistic which is either 0 or positive. So as compared to the skewness, where we could take 0 as a cutoff value, here we need to have a different cutoff value. Well, we can help ourselves, and so far that we can assume the normal distribution to deliver more or less this cutoff value. The normal distribution here, that's a fine lined curve, has a kurtosis of 3. So we can decide whether the kurtosis is actually larger or smaller than it would be for the case of the normal distribution. And we have two possibilities here in this case. I'm going to start with the right one first. Here it's much steeper than with the normal distribution. This means that our values are pretty close to the mean. So we have very rare cases of outliers, very few outliers, especially when compared to the normal distribution. So all the values are very close to the mean. So this also means that we have a relatively homogeneous data set. On the other hand, we can have a situation as the one here, that we have quite a lot of outliers as well. So our values are not as close to the normal to the mean as with the normal distribution. This case, thereof, if this means we have relatively homogeneous data set, here we have a relatively heterogeneous data set with a lot of outliers, even further apart away from the mean than it would be the case in a normal distribution. And well, the left case we are also calling platykurtic. That's the case if the kurtosis is smaller than 3. And the right case, where we have a relatively steep distribution, values being much closer to the mean, we call leptokurtic. Here the kurtosis is larger than 3. Well, how to make this a bit easier? How to make it a bit more comparable to what we do with the skewness, for this we could also introduce the so-called excess as an additional statistic. The excess is simply the kurtosis minus 3. So if the excess is negative, it's platykurtic. If the excess is positive, it's leptokurtic. If it's exactly 0, then it has the same kurtosis as the normal distribution. That's actually an interesting point, because if, for example, you use Excel for the calculation of the kurtosis, Excel could also give you negative values. That's because even though Excel says it calculates the kurtosis, it actually calculates the excess. Well, that's then everything there is to this unit on calculating measures of distribution. Hope you enjoyed this session. I say goodbye and see you next time.